talk about is congruence and transformations. Two geometric figures are congruent if and only if there is a transformation or a combination of rigid motions that maps one of the figures onto the other. Okay, so congruent figures will have the same size and shape, which means they'll have the same area and perimeter as well. So my first example wants me to find any congruent figures in the plane. So I am going to start off by looking at my squares. This square is a 2 by 2, and this square is also a 2 by 2, so they are going to be congruent. I just label the squares by all of their letters, so I have A, B, C, D is going to be congruent to P, Q, R, N. Okay, then if I look at my triangles, this one is 2 and 2 on its sides, this one is 3 and 2, this one's 3 and 2, and this one's 2 and 2. So the two triangles that have side lengths of 2 and 2 go together. So I have HIJ. This one gets the triangle symbol. And then my other triangle that matches up with it is STU. And then my next pair of triangles is EFG. And the one that has a side of 3 and a side of 2 is KLM. Another name for a rigid motion or combination of rigid motions is a congruence transformation because the figure remains the same size and shape of the original. So this one wants me to describe a congruence transformation that maps parallelogram ABCD to parallelogram EFGH. So I want to figure out how I go from this shape to this shape. So the first thing I noticed is that they're facing opposite ways. That means I'm going to do a reflection from this one to this one over the y-axis. So A is 1 away, so my A prime is going to be 1 away on the other side. B is 3 away from that line, so I go 3 to the left. for my B prime. D is 2 away, so 2 to the left for my D prime. And C is 4 away, so I go 4 to the left for my C prime. Okay, so now I have my shape facing the correct direction, but it's not completely on top of the other one. So what I want to do is I want to figure out how this shape is moving from here to here. So to go from A prime to E, it's going down 4. So this is following the rule. XY goes to X comma Y minus 4. And this is a translation, because it's just sliding down. Okay, so this one wants me to identify any congruent figures in the plane. So I'm going to list out their side lengths before I can decide if they're congruent. This rectangle has a side of 2 and 1. This triangle, the only flat side I have is 3. This triangle, again, the only flat side I have is 3. These triangles have sides of 2 and 2. And this rectangle has a side of 2 and 1. So I just need to say which shapes are congruent. I have GHIJ is going to be congruent to the other rectangle, which is NPQR. Then these two triangles appear to be congruent. So then I have triangle ABC is congruent to triangle DEF. And then I have these two triangles down here. So I have KLM is congruent to STU. This next one wants me to describe a transformation that maps triangle JKL to triangle MNP. So first of all, I need this to flip in the right direction. I can either choose this one or this one. Do you want me to pick X or Y axis? X axis? Okay. So I'm going to flip it this way. So it is, L is 2 up, so then I'm going to go 2 down for my L prime. K is 4 up, so I'm going to go 4 down for my K prime. J is 2 up, so I'm going to go 2 down for my J prime. And then J is 5 away from M. So this transformation is going to be xy goes to x plus 5 because I added 5 to my x value, y. I have reflections in parallel lines theorem. If lines K and M are parallel, then a reflection in line K followed by a reflection in line M is the same as a translation. So if I have a double reflection in lines that are parallel, results in a translation. So if I take a look at this, the line AB reflected over K turned into A prime, B prime, and then reflects over M, turns into A double prime, B double prime. This line is just slid over, which is kind of hard to see without being on the page. So if A double prime is the image of A, then A double prime is mapped to A prime and A double prime. And the length of A double prime is double the length between K and M. So the same thing goes for B double prime. Okay, so my third example says, in the diagram, a reflection in line K also maps GH to G prime H prime. A reflection in line M maps G prime H prime to G double prime H double prime. Also, HB is 9. So from here to here. Oh no, wrong way. From here to here. And DH double prime is 4. So right here is 4. Name any segments congruent to each segment, GH, HB, and GA. So GH is this segment right here. Any of the reflections are going to be congruent to GH. So I have GH is congruent to G prime, H prime. And that's going to be congruent to G double prime, H double prime, because reflections keep congruence. Then for HB, that's the one where I wrote the 9. B prime or BH prime is going to be congruent to that because reflections are the same distance away from the line they're reflecting across. And then GA is this line segment right here, so it's going to be the same as A G prime. So B is asking if AC is equal to BD. So right here, if this is equal to this distance right here. This answer is going to be yes, because parallel lines are equidistant. And my final question is, what is the length of G prime, or double prime? So first thing I want to do is I want to figure out the length of this orange piece I highlighted. So because HB is 9, I know that BH is also 9 because those two are congruent. I said it right here. And then DH double prime is 4, so H prime D is also going to be 4. So this entire orange piece is 13. And then in part B, we said that that orange piece is equal to the yellow piece, so that's also 13. And up above, we said that A double prime is going to be double the length between K and M. So the length of G double prime is going to be double the length between K and M. So I just do 2 times 13, which gives me 26. So the next theorem is reflections and intersecting lines theorem. If lines K and M intersect at a point P, then a reflection in line K followed by a reflection in line M is the same as a rotation. So when I have two lines that intersect, if I reflect and then I reflect again, it results in a rotation. The angle of rotation is going to be 2 times my x degrees, where x is a measure of the interior angle formed by lines K and M. So for this one, I'm looking at these as my lines of intersection. So I take this inside angle, which is x, and I double it for the entire thing for my degree of rotation. So number 4 says, in the diagram, the figure is reflected in line K. The image is then reflected onto line M. Describe a single transformation that maps F to F double prime. So I'm looking for this fish to go all the way over here. So by using the reflections and intersecting lines theorem, I'm going to take 2 times 70, because 70 is my interior angle, which just gives me 140. So this is, which fish started off? This was my first fish. So 140 degrees counterclockwise. This next one wants me to use the figure. It tells me the distance between line K and M is 16 centimeters. It says the pre-image is reflected in line K, then in line M. Describe a single transformation that maps, that's not helpful, I can't see the colors, the blue figure to the green one. I assume it's P to P double prime. So I'm looking for going from this triangle to this triangle. Because they're facing the same way, this is a translation. And without it being on a grid, I can't say by how much. No, these also didn't show up very well. This one's P prime, and this one's P double prime. B is asking what is the relationship between P and P prime in line K, and explain. So P prime is the reflection of P over K. Okay, and then C is what is the distance between P and P double prime. This is the theorem we learned at the top of the back page. So I just take 2 times the distance in between, so 2 times 16, which gives me 32 centimeters. And the last one, it says in the diagram, the pre-image is reflected in line K, then in line M. Describe a single transformation that maps the blue figure onto the green one, which isn't very helpful. Oh, they're not even labeled. So I'm going to label them so I can tell. So I'm starting at this one and I'm ending up over here. So what I do is I take 2 times that 80 degrees, which gives me 160, and then I went counterclockwise. B is a rotation of 76 degrees, maps C to C prime to map C to C prime using 2 reflections. What is the measure of the angle formed by the intersecting lines? So I'm going to draw this picture out. So if this is my C, then this is my C prime, and this whole thing is 76 degrees. So I'm looking for the angle on the inside. So I just do 76 divided by 2, which gets me 38 degrees.